Chapter 3, we're going to talk about molecules, compounds, and chemical equations. This is where it gets to seem a little more like chemistry. So, how many different substances actually exist? That's a question that I don't know that could be really answered. A substance is a particular instance of matter. It could be a compound or an element. We do know that there are 91 naturally occurring elements, but those elements combine with each other in different ways to form compounds. And there's an almost limitless number of compounds. You cannot combine any two given elements however you want, but there are many, many different combinations. And the great diversity of substances that we see in nature and in the things that we have created is a direct result of elements being able to combine with each other. So let's look at hydrogen and oxygen. Start simple. So we've got the elements, hydrogen and oxygen. Here we have a table showing some of the properties here. Hydrogen is a gas at room temperature. Its boiling point is negative 253 degrees C. You can get liquid hydrogen, but it's not easy. And it's very flammable. It's explosive. Oxygen is also a gas at room temperature. Its boiling point's a little higher, but still well below 0 Celsius. Oxygen itself doesn't burn, but it is necessary for combustion. And so the combination of these two as a mixture is pretty dangerous. And then if we combine these into a molecule that we call water, now the boiling point is plus 100 degrees. It's a liquid at room temperature. And water is a substance we use to extinguish flames. So there's a vast difference between the properties of the elements and the property of the compound they form when they're combined together. So two or more elements combining to form a compound, we've got an entirely new substance, completely different than what was before. If we have a mixture of hydrogen and oxygen, you can have any proportions. You could have 1/10 hydrogen and 9/10 oxygen, or vice versa. You could vary it around. Water, though, is a compound, and the proportion's always the same. There are always 2 hydrogen atoms to every 1 oxygen atom. And that is like the most intrinsic difference between a compound and a mixture. Compounds have a definite proportion. We talked about that law. A mixture can have varied proportions. So here we have a balloon, an illustration of a balloon, hydrogen and oxygen mixture. Here we have 2 different types of particles. Here they happen to be molecules, but we've got oxygen molecules and hydrogen molecules, and they are separate. There's different kinds of particles. This is highly flammable. Here we've got a glass of water, and if we look at the particles of that, all the particles are the same. They're individual molecules of water, 2 hydrogens to 1 oxygen.